Hey guys, in this video we're going to be going over primitive types in Java. So the first primitive type we're going to look at is something called an integer. So an integer lets us store whole numbered values. So we can store 20, 30, 5, 4, 3, negative 100, and so on. Basically just any number that doesn't have stuff following the decimal point. If we do want to store a number that has stuff following the decimal point, we use something called a double. So a double lets us store something like this, 20.25. Alternatively, we could store 30.1 or 50.22222 and so on. So both of these are useful, but suppose you wanted to add an integer with another integer. Okay, well that's pretty straightforward. Well, you can just do myInt plus maybe, let's just add 10 to it. So this does exactly what you would expect. It fetches the value of 20 from myInt, and then it adds on this value of 10, which gives us 30, and then we store it in the sum variable. Okay, now what if we tried to add the integer to the double? Well, this is going to give us a compiler error because we're fetching the value for the integer. We're fetching 20, and then we're trying to add it to the value of the double, which is 20.25. So the result is 40.25. But remember, we can only store whole numbers inside of integers. 40.25 isn't a whole number, and so we're not allowed to do this. The solution is basically to do something called a cast. So what this cast does is it takes the result. So it takes the result of 40.25 and it just truncates everything following the decimal point. So we're just gonna be left with 40 after we apply this cast operation. Okay, so that's pretty straightforward. So now let's look at another example with something a little different, with something called a Boolean. So a Boolean just lets us store one of two possible values. It lets us store true or false. So let's say that we declared our Boolean like this. So Boolean, you can think of it as an integer, or basically like an integer that stores either 0 or 1, where 0 is equal to false and 1 is equal to true. So why would we ever use Booleans? I mean, they seem pretty useless, right? We're only able to store one of two possible values. Well, they become useful when we use something called an if statement. And we're going to be going over this in later videos in more depth, but just, it's good to have a brief introduction. An if statement, you can think about it as checking to see if the stuff inside of these parentheses, resolves to true, then we're going to go inside of this block and we're going to execute whatever is inside of here. So think about a real world example. You could say that if it's rainy, then take an umbrella outside, right? So let's is rainy. So if it's rainy, and we're going to say that it is rainy, we're just going to set the value to true. If it's rainy, then let's print out you need an umbrella. It's as simple as that. If we were to run this, we would see that we would need an umbrella because we had set the value of is rainy to true. If we had set it to false, this wouldn't be printed out because this condition, it wouldn't be satisfied. We couldn't go inside of this block because is rainy is false. And so that's really why you would want to use bools. Let's go over another data type now called char. So chars, or characters, they let us store character data, as the name implies. So let's create one right here. So inside of this myChar variable, we can store A, we can store C, D, E, F, P, maybe even I, so on, right? Whatever we want. Now, suppose we stored the letter 9. So is this the same thing as doing, are these two things the same? Are they equivalent? And the answer is, perhaps a little surprisingly, no, they're not the same. Inside of this 9 variable, we're storing the numerical value 9. So we're creating a block of memory, and then we're storing 9 inside of it. Okay, well, it seems like we're doing the same thing here, right? We're creating a block of memory, and then we're storing the 9. or the letter 9. But the difference is the letter 9 is different from the integer value 9. And the reason for this is something called ASCII. So a computer basically, whenever we like on our computer type the letter A, right? What is going on? Well, the computer takes this A and it converts it to a number. Maybe, I don't know, 50 or something. Maybe 57. It converts it to a number. So then after it converts it to a number, then it converts it to a sequence of zeros and ones. So it converts it to a sequence of zeros and ones, and then it can use these sequences of zeros and ones to actually do stuff, right? Conversely, when it has this sequence of zeros and ones, it can convert it back to the number 57, and then it can convert it back to the letter A. Okay, fair enough. Now, suppose that we decide to store this letter 9. So what it's doing is it takes the letter 9, right? And then it maps it to some number. So it might map it to the number 37. And then once it's mapped it to the number 37, it maps it to some sequence of binary, basically. Right? So this is completely different from starting with the number 9 and then ending up with some binary sequence, right? So the binary sequence for 9, let's just write it out. 1, 2, 3, 4, 5, 6, 7, 8 spaces, right? So the first one we get a 1 in there. 1 plus, how do we do this? 1 plus 2 plus 4, that gives us 3 plus 4 is 7. Or no, we can just do this. 1 plus 8. Right? So this is the binary sequence for 9, and it's completely different from the binary sequence for 37. Okay, so that's a little bit of brief intuition behind it. In this case, this isn't not the actual binary sequence. So this is just to give you some kind of intuition. Okay, so now let's just print out the character. If we were to print it out, we would see that, yeah, we do get a value 9. We get this character value 9. But is there a way to extract this number that 9 maps to? So the letter 9, it maps to a number, right? So is there a way to extract that number? And we can do that by declaring another integer value, and then using this cast operator, or using this cast operation that we had defined up here. So when we were using it to convert a double to an integer, what it was doing it was taking this double value of 40.25 and then just trimming it, just getting rid of this 0.25 and leaving us with this 40. Similarly, we're taking this integer value, we're taking this character value that has, this letter 9 stored in it, and we're fetching the number associated with it in this ASCII table. And now, if we were to print it out, we get 57. So this actually maps to 57. And then I guess the A maps to something completely different, maybe like 86 or something. Okay, so that just gives you some brief intuition for how characters work. So characters, they're useful because we can, they're not very useful in this case because you can only store one character at a time, right? But suppose we decided to store multiple characters added onto each other, right? So we could store A, and then we could store B, and then we could store C. Well, is there a way to take all these characters, and somehow add them and then store them in one variable? And it turns out there is. We can use something called a string. So we're going to go over strings in more depth later. They're very powerful, but for now, just remember that strings are a collection of characters, or a sequence of characters that you can work with. Anyways, that wraps up this video. I'll see you guys in the next one.